Bon, comme vous savez, l'heure c'est l'heure, midi 15, 11h15. Bonjour à tous. Je m'appelle Arnaud RIMOKH, je suis directeur délégué drone à Aerospace Valley, qui est un pôle de compétitivité. Nous avons la chance d'avoir été invités par un autre confrère pôle, qui est le pôle DERBI, qui est présent sur cet événement. Et donc nous avons la joie aujourd'hui de vous parler drone et énergie renouvelable sous forme de cet atelier, donc un atelier qui durera 1 heure avec 3 intervenants. Et autour de cet atelier, j'ai le plaisir de vous avoir à votre disposition Octavian Curea, donc qui est professeur en génie électrique, docteur à l'Université du Havre et ingénieur de l'Institut politique de Trajan Vuya Timișoara. Et depuis 2004, il est enseignant-chercheur à
We are starting this session on drones. We have various panelists, Arnaud and Octavian Curea. I will be the first speaker to present the market. Then we'll have Octavian, who is a teacher in electrical engineering in Estia. And then he developing drones, and he's conceived of he will talk about today. For Alex is this, and he is a technical expert in. We have 4 points of view: the point of view of a pole of competitivity, the point of view of a research drone manufacturer, and myself. I will the drone industry and how it can play a role. Just a few words on us. We are we have together 8 and 60 small and medium-sized companies. We and we have 150 small companies at the service of developing airspace. Companies working for developing drones, including the Toyota company. This is the full range of players, funders, local authorities, businesses. They cover the entire chain of drone manufacturing, from designing to drone surveillance and security, national security. And we have been working with a budget of more than 90,000 euro. We have been able to collect some funding for our members, and we are also present at European level. We are experts for the European Commission, especially for what has to do with 2.0 drones. This is a market that has accompanied the development of the energy sector. We've had 2 recent market studies that are confirming this. ATAS systems. This is to distinguish terrestrial, airspace, or submarine drones. So whether they be flying robots, rolling robots, or underwater robots, they are all part of the renewable €2 million, most of it for air drones. There is a market for drones we have a growth rate which is spectacular. You could have drones for renewable energies, but they stick to new requirements of our societies, whether it be in terms of risk reduction for people working in that branch. We also need to guarantee the continuity of production, of energy production, and drones are useful in in the building industry as well as in maintenance. They also have a role to play for transport, the transport of electricity. They can also reduce all losses associated to maintenance and stoppages. They can also reduce risks for workers on plants. And drones can be used also to help implementing renewable energies. You probably heard about the story of wind turbine that had to be stopped in order to protect local fauna. So all the players in the renewable energy sector are collecting data using drones. They are protecting their properties. And having drones in that sector is also a factor to attract young people and new competences. It also allows for outsourcing. You can use service providers, some of them are here in this meeting, or on some stands, Instadrone, for instance. So you can use, you can outsource your services so as to more rapidly deploy your drones and reduce your capex investments. And then you don't have to develop so many complex softwares. You only use a service. Drones are present in all renewable energy plants, whether it be wind turbines, hydroelectric, or any kind of renewables. And all along the chain, you can use air drones so as to appropriately operate your plants. Here, you can see a few examples of companies who which use drones, for instance, to inspect wind turbine blades. You can see that picture on the top left, which is very impressive. You can see the erosion here, or damage caused by salt or wind. You can see small lines, and you can see the wear and tear on the blade. So with the drone, you can actually get pictures so as to more efficiently inspect your equipment. Drones. When you use drones, you can reduce your inspection cost by 80%. I would like to bring your attention on to our drone experts in this region. We have the DERBI company, for instance. And here in this region, there are companies like Aerospace who can provide services, as I said. You have DroneVol carrying out topographic analysis. They even use a car share. You can see that the picture here. I have a picture of DroneVol. You can see here a car share, a high pressure system that cleans, a power blaster that cleans that wind turbine. What are the applications for solar plants? We have Unmanned, which is a PV plant that produces energy for the city of Bordeaux. They use drone to inspect their sites, and they use a drone with thermal cameras for maintenance. So that drone identifies defects on solar panels. They have about 100 solar panels to change every year. And there are other players on the territory, like Scalion. They have developed an inspection service for solar farms. They have they set up some cartography, some mappings of all the panels, and they identify defects. They can identify those defaults and generate some maintenance operations. All this is made in France. And before giving the floor to the other three speakers, a few words on our challenges. In my view, legal aspects are no obstacle. They can be part of the solution. It is not very complex to operate drones in the renewable sector. In the future, we will integrate IA into processes, and we will use ever smaller sensors. So we will optimize our drones so as to in turn optimize yields of plants. We now use drones as an eye, but we will use them as an arm to actually maintain plants. They will be able to carry equipments and change spare parts. We are also developing systems as to avoid wildlife, birds, and take the environmental dimension into account. Without further ado, I will give the floor to Octavien for his part as a project leader. Octavien, you have the floor. Thank you.
Thank you very much. So I'm Octavien Correa. I am a professor at the Estia Engineering School. I want to talk to you a little bit about a project that we have been working on. It's a sustainable project. So for sustainable projects, the idea is to include aerospace robotic technologies for renewable energies. So this project has been funded by Interreg and Atlanticara. There are 13 participants. They're representing 5 different countries: France, Spain, Portugal, England, and Ireland. The partners are universities, manufacturers, technologists, and research centers. The idea was to start by mapping out existing technologies and needs so that we could identify what already exists on the market. In the 3 years of the project, it was quite difficult to create new measures, and we also wanted to identify what the energy players need. So we started by adapting navigation technologies and adapting maintenance and repair technologies. So it's all very well and good detecting, then you have to act. And so at the end of the project, we wanted to come up with a model, with a mock-up of a solution that could be used on pilot sites. So let me tell you a little bit about the mapping activities. There were several solutions that were adopted. We had 515 participants, 3 consultancy firms, and a lot of B2B. And that meant that we could identify the solar production sector's needs and the wind production sector's needs. We could identify aerospace and robotic technologies which would correspond the best. And then we're going to start by talking about navigation and surveillance. For this particular part, we started with UAVs, i.e. vehicles with no humans, and we analyzed the time it took to locate, for the drones to locate what was needed, and we also worked on their trajectories, because if you have to check a wind turbine, you need to have complete knowledge of where the blade is and be able to monitor that afterwards with the drone. So we also used higher functionalities such as 3D mapping, object recognition, and mobile object monitoring and the detection of obstacles. We're talking about systems with relatively limited calculation power. So we had to find real-time strategies with, which didn't need a lot of calculation, whilst adapting to 3D environments, because we were really out in the field, real-life situation. So it was real-life 3D. Continuing to talk about surveillance, not necessarily navigation, we're talking about surveillance now. We had a project on non-destructive tests. There were several technologies that were tested. Different types of inspection for the different panels, inspection of the blades, techniques of technoscopy, and ultrasound inspections also. That was supposed to be done by an air vehicle, I know UAV, and same thing for the thermographic inspections of the solar panels. For the ultrasound inspections, the idea was to take the technology via the drone and carry out that non-destructive test directly on the blade, which was still on the turbine. To be able to manage all of this in terms of navigation and surveillance, we had to work on the user, i.e. the human being who was managing the drone. So we used augmented reality and virtual reality to do this. For example, for remote monitoring, you can have augmented reality whereby you get a video feedback from the camera, but on top of that you can add further information. The virtual reality environment means that the entire environment has already been mapped out, so you've got a 3D model of the area in question. In order to put all of this in place, we had a virtual cockpit ready to work with our virtual robots, both in the sky and on the ground. Now I'm going to move on to talk about adopting technologies for maintenance and repair work. Several technologies were used, and we, for example, analyzed processes for LMD materials, i.e. heated via laser, the manufacture of bigger spare parts using the arc. So if you have to create a big spare part using LMD, it takes a lot of time. But with arc technology You won't have the same degree of precision, but you'll be able to make that spare part much more quickly. So if we need to broach more complex forms, shapes, then we have a different technology to use. And we can redesign also, as you can see here where I'm pointing to with that green dot there on the slide. We redesigned a part. It's got the same original shape, but we've optimized it. That means it uses less material and reduces the weight of the part also. We also focused on repairing damaged parts by adding different things and manufacturing broken parts on the spot thanks to these technologies. For composites, we worked on automated repair work. For example, we used laser technologies to remove the top layers and redo those top layers completely without dismantling the blade from the turbine. So we were working in situ. That enabled us, that meant that we had to have perfect control of the drone if we wanted to have repair work of top quality. But I'd like to remind you that this is just a research project, so we went as far as we possibly could. But that doesn't mean that that could be replicated on an industrial scale. We've talked about remote control and this onboard arm to carry out repair work. So we need, if we're going to do repair work, we need an arm, an articulated arm, and virtual and augmented reality both helped us on this score. Here you have on the screen an example of a test project which we worked on. We used sensors on the operator's arm, and we could thereby make the robot arm move. So there's a natural interaction with the robotic arm that meant that we could manipulate objects and carry out maintenance tasks. All of this, of course, required quite a lot of work. We used some pilot sites. There were 2 case studies, one for wind turbines and the other for PVs. Here you have photos of the 2 examples. Here you can see the drones. One's next door to the turbine and the other is floating above the PV panels. Today, we count a lot on operators which are on site, but sometimes it could be very useful to have someone remote, an expert, for example, who can go even further in the diagnosis, someone who can better manage the repair. And to this end, we worked on VICE, the Virtual Immersive Cockpit Environment, VICE. This software solution is a way of supervising and controlling your drones in the air and on the ground. And it really is anchored in virtual reality. The idea here is to enhance the pilot's experience as much as possible by reducing the workload, giving the pilot the notion of being as close as possible to the system, and giving the pilot an opportunity to interact really easily, we developed different tools linked to the task. So for each type of task, we had a different tool, like building blocks, if you like Lego that you can piece together in this virtual cockpit. And we also developed a sandbox where we could test new functions, new technologies, without breaking the real equipment. So the new functions could be based on 3D maps or geodigital vehicles, on the display of data, like a head-up display screen, video vectors, and altitude control when you're talking about an airborne drone. So in this particular solution which we put forward, we created some bridges to join together different types of drone, both airborne and ground-based. We created some different footbridges, as you can see here, which meant that we could control as many drones as possible. The solution can, of course, evolve in the future. We'll be able to integrate other bridges if necessary. And here we have an example of a wind park. This example was created jointly with a company called RIMOKH, and we were demonstrating hardware in the loop. So we had a team that was on site. We had a 3D representation on the ground and a real-time simulation whilst integrating the presentation of real characteristics for this type of system. So I don't know if I went speedily enough. Perhaps there'll be, I don't know if there's time for questions. We'll see later on. Thank you very much. Well, you took 15 minutes, which was your allotted slot, so well done. So after that European project, I'm going to hand the floor to an industrialist now, Cédric Lefort from the company TDAV. Thank you very much, Arnaud. We're not yet industrialists. We are still a startup, but we have ambitions to become industrialists, of course. So in a nutshell, I am the president and co-founder of TDAV. This is a company that is based at the National School for Civil Aviation in Toulouse. We are at the very heart of that site, and we're right next to the biggest drone park in Europe, which means that we can carry out all of the tests that we want to. I'm just trying to work out how my remote control is going to work. So we want to collect aerial data, but when there's a strong wind, it's very, very difficult, particularly by robots. It's a big challenge today to collect aerial data when the wind is high. So for over 10 years, I've been working with drones. At the outset, I was an engineer for Toulouse Tech Transfer. So I was working in a research lab in Toulouse. And we worked on maturing and transferring technology towards industry and major clients. I'm not going to list them all, but it's not very important. But the important thing is that we realize that the first enemy of a drone is the wind, whichever configuration you're talking about, because we tested absolutely all of them. So we focus on the offshore market with our innovation because we didn't want to get drones flying over islands. What we wanted was to comply with regulations. That's the first point. And because we created a drone which resists the wind, we thought that the offshore market would be great for us. We had long range. Also, we needed to be able to fly fast and far and resist the wind. These were the main key points. And because we were very precise in our flights, we were able to take off and land vertically, and that meant that we could carry out or comply with certain applications. And so there aren't very many people flying over the sea, so it wasn't much of a problem for us. So we carried out a survey, a market study if you like, and we identified how many competitors there would be in offshore wind turbines. Of course, helicopters are a rival of us. That's why helicopters were first invented to fly over the sea, not over the land. That was really clear. So we are echoing the development of helicopters, and that's fine with us. Multicopters, everyone's familiar with these. This is an indirect flight mechanism to make movements. You take one angle, and then you translate a different movement. That is something which works very well at low speed. However, at high speed, it's rather difficult because the faster the thing goes, then the more it inclines. So it's very, very difficult. There are aircraft drones, which are also interesting, but they need all kinds of infrastructure. They need to be launched properly, but they're also very fragile because of the landing phase, well, it's a bit tricky. And then there's the VTOL. This is where we specialize. These are vertical takeoff and landing devices. And we know that the problem here was on stationary flight because all very well and good, you take the drones which are traveling around, that's fine. And then you have to come and drop that onto an aircraft. And when you're in a stationary phase, if you're asking that machine to do a translation movement, it's going to tilt and will be unfavorably exposed to the apparent wind. And that creates instability in face of the wind. Especially if you've got 30 or 40 kilometer wind, nothing else can nothing can fly, and it's a catastrophe for everybody. So we created a new model. It's a TH3. This is a device which is quite spectacular. It can withstand 35 knots of wind. There is no equivalent on the market. It weighs 20 kilos and it can have a workload of several kilos. It can hit 150 kilometers per hour in speed, so it goes very, very fast, much faster than current solutions. And it works because we can manage the 6 degrees of free movement. We can always make sure that we have the favorable wind for our flight. So when you want to go forward, then you don't tilt the front of the device. We're not tipping our nose down. We will have a favorable angle. When we want to go sideways, as you can see, it travels laterally with a minimum wake because it is not exposed to those winds. And so it flies very, very quickly. And so what do we do with this magnificent invention? We worked on this in partnership with ENAC. So the advantages are permanent availability. It's very economical because it is just a drone. There are no human beings there, only on the ground, of course. There's an operator on the ground who supervises the work. It's very quick to deploy because we don't need any infrastructure whatsoever. So what are the markets were interesting? Well, wherever you need speed and availability, i.e. in security, and doubt removal. So when a project is being set up, for example, I'll tell you about our business model in a minute, but we worked with the Open Sea Foundation working on wind turbines, and little step by little step, we didn't aim for the stars to begin with, saying we were going to inspect the blades. What we wanted to do was remove any doubt. So you can be launched from a ship, and because we're completely available, we can find out what's going on. if there's been a break-in or someone has, some boat has crashed up onto a tie line. Goodness knows what might have happened. All kinds of things can happen. But it has been recognized by all of the industrialists that that will work with renewable energy and more industries than that, of course. This is a dual activity. That means that we have civil applications and military defense applications. It's always the same theme. We're with tugboats, for example, with missions of civil security. And there's a program that's going to be starting in a few months where we will be testing our models, because they are flying actually, to make direct flights from the boat. That means that we will be able to go ahead of the boat. If a boat is a bit unsure about something, if there are migrants, for example, on the sea, if we need to give them help, then we have to kind of go, we send the drone ahead of the boat to check the situation. The same thing for questions of pollution. We just want to go and check out, scope what's going on remotely. So that's a wonderful project. And I would also like to underline a project which is starting at the beginning of 2024. It's a CITEF program. And here we have a consortium with ONERA and the French Oil Federation. And we have a mass spectrometer. We analyze the atmosphere. We can analyze emissions from industrial sites, and we can identify what the impact is on the environment, which is perfectly in tune with what's going on today and European regulations. So there are some big clients who've already sponsored the project, Total, Toyota, and all kinds of big companies are on board with this one. Our business model, as I've already said, is to know, it's identifying whether it's economically feasible, and then after that we can provide services, because we can go and acquire data, and data, as we know, is so important today. We need to know what's going on. We can use a robot to go and collect data from tens of kilometers off the coast. And we're not going to be flying at 30 kilometers an hour. We can take off at 60, and we can also come back against a headwind. So that's very good. It's all very well being able to fly with the wind at 60 kilometers an hour, but not being able to get back. That would be a problem. That's not our case. And then we will be able to crunch the data. We don't do interpretation yet, but we will be able to do that in the future. And we can also sell drones as well, because there are different defense applications which might be of interest, and the Navy might be interested as well. So thank you very much. And I'd like to thank DERBI as well for enabling us to present our TIDAF company. And if you'd like to learn more, don't hesitate to get in touch with me. Thank you very much. So as you've seen, there's a lot of talent in our region. Let's move on to the client, and the client is the client always knows best. As we know, I'm going to hand the floor to Philippe Alexandre from NG Green, who's going to talk a little bit about their experience with drones. Good morning. So I am going to talk to you mainly about drone applications in the field of renewable energies. When I'm talking about these REs, I'm referring to wind turbines. Whoops, I'm having a bit of trouble here with my earphones. Says the speaker. So when I'm talking about renewable energies, I'm talking mainly about wind turbines and solar energy, which are the specialist fields of NG Green, the company with which I work. So let me talk first of all about drone applications, mainly for thermography of solar plants. There's nothing more like a PV module than another PV module, apart from the fact that fortunately PV panels heat up. And they don't heat up in a uniform manner. And so that can be used as a defect signature. So we use drones to take photos, normal photos if you like. These are infrared photos, thanks to onboard infrared cameras which are on the drones. The drone flies over the plant, the power station, and has been pre-programmed to take photos. There's an operator on the ground, of course, to make sure everything runs smoothly. So our drones fly at 25 meters off the ground on a programmed trajectory. And the drone takes all of the photos of all of the panels. So this is the kind of work that we carry out on all of our sites. We've got 193 sites. We usually work when irradiation is sufficient, i.e. between March and August mainly. We can process a plant of 10 megawatt, that's about 10 hectares of land, in one single day. And so after we've made our thermal inspection, we can identify the defects with that infrared signature. And the goal here is to change faulty panels, because it's not easy to repair a panel. It can be done. We can replace a diode, or we can replace the sheet behind the panel, but it is a bit of a tricky structure. And it's all very encapsulated. And so we prefer to change a panel if there's a defect on it. So let me give you a few examples. This is not exhaustive at all, but there's just some examples here of defects that the drone might pick up. So broken panels. This is when there's strimming done, when the grass is trimmed, pebbles can shoot out all over the place and break the glass on the panel. It's not necessarily a problem in itself. However, it can let the dampness seep in, and in the long run, it will create problems with certain cells, and it will release some of the current and make the panel less effective. So here you can see, on where I'm pointing my green dot, you can see that there are some white patches there on the edges. This is not an infrared photo, this is a normal photo, and it just enables us to identify this kind of defect. We've got some hot spots also. Follow my green dot. There you can see some hot spots. These are bright spots which show that this cell is overheating because they're old or because there have been some kind of impact. It also can be due to hailstones, strong hailstones falling down. We've also got faulty diodes. Here you can see these strips that show that some of the diodes are overheating, the diodes are not working properly, and you also have some current which is seeping. We would analyze this towards the bottom there, you can see. Well, no, you can't really see it very well, but this photo shows us that there has been a migration of electrons. So that's the seepage thing. The PID box is used to correct that, and we can see that with thermographics. There are other types of defect which are less serious. We don't really need to replace the panels for these defects. When they become dirty, for example, they have bird droppings landing on them, because bird droppings can in fact create problems of shade and overheating. All we need to do there is clean the panel, and then the grass can grow, the plants can grow too tall and create shade. Here you can see the infrared image, bottom right, and there what we need to do is to go out with our strimmers and trim the grass.
Alors des applications dans l'éolien.
What about applications? Well, first of all, visual inspection of wind turbine blades. Why? Well, because blades get damaged over time, and blades are a quite fragile component, and they undergo very strong pressures. They can there can be shocks with birds, for instance, or episodes of thunderstorms. So blades can be damaged in many ways. So we use drones to take pictures with high-resolution pictures of the blades. And a drone can go along a pre-programmed trajectory and take pictures. You can see the red dots corresponding to various pictures. 1 millimeter on the blade corresponds to 1 pixel. We can do as much as 15 meters per second. And what do we do with all those pictures? Well, first of all, we put all the pictures together. We assemble them so as to show all the facets of the blade, the front, the back, and the profiles. And our experts can watch these pictures on huge screens and try to identify all defects and all damages. They then produce a report. We cannot do this on all blades. We try to have a rotation on a yearly basis. In 2023, we inspected 100 blades or so. Another type of applications, the watching the path of thunder, of lightnings. We therefore use a service provider that controls the lightning path, so to speak, on the blade. So we check the blade all along. There is a copper cable that runs along the entire wind turbine all the way down, and it's connected to the ground and in the concrete structure at the basis of the turbine. So we're creating a closed circuit between the drone, which connects onto that orange part. It connects onto a patch that sticks out of the blade. And you then have a closed circuit, a closed loop between the sensor of the drone, the cable, the earth, and the equipment, the aerometer that controls that structure. And we can check whether this entire loop is valid. That control takes place in less than half an hour. In the past, we couldn't do that type of inspection. We could control the blades only by removing them. So we wasted a lot of time. Now we can inspect blades in less than 30 minutes, so we can have more systematic inspections. It's a great advancement. Third application, measuring wind speed so as to evaluate the performance of the wind turbine. This type of services is experimental so far. We work with an Israeli company called First Airborne. So we use a weather vane, an anemometer On the drone, it measures the wind, and this anemometer is used upstream the wind turbine, and we measure the direction of the wind at any moment, and we check the information on the speed of the wind and the production of the turbine at a given time. Then we can check the power, the operation of the wind turbine. We can detect misalignments. We can also inspect devices located on the top of the turbine, and so on. There are many ways to measure the speed of the wind, which are very reliable, like a man measure, but this is much more costly, around 100,000 euros. So this system with drones is much less expensive. To conclude, as you can see, using drones is easier, so it brings down costs and it makes work more efficient, and we can then deploy the use of drones so as to be more efficient. And there's a bright future for drone using in the renewable sector. There are many innovations underway. We are developing a drone equipped with power cleaner that cleans the blades. At present, we can't clean blades at all, or we do it from time to time using some scaffolding on the turbine, which is very heavy and lengthy. It's a lengthy process, so we can use drones to do that instead. So these are some examples of projects in the way we use drones for wind turbines. Thank you very much. It's great when clients give us the examples. We have 5 minutes left for questions from the audience. I think we have microphones around the room if you want to ask a question. Yes, I have a question for Angie. Did you internalize this drone competence, especially for PV? Can you repeat your question? Did you internalize that skill at Engie's, including for PVs? You talked about deploying such operations. No, not yet. Not at present. It would take a lot of effort. As you saw, applications are very numerous. Perhaps we could do this for PV, but we outsource. We work with experts. It takes a lot of energy to reach that level of efficiency. We have a lab internally specializing in drones, but it is dedicated to innovating and developing other uses for drones. The examples that were given here are dealing with maintenance, but we could also imagine drones for project developments. Perhaps we could have drones with LiDAR that could be used for topography. We have worked with various labs within ENGIE, but we work with external operators. Hello, Gérard Fleury. I worked at INRS. We work on preventing occupational injuries. I have a question on PV. It's great to develop PVs. A lot of them are being set up on roofs, but we are quite preoccupied with maintenance issues. Falling from heights are one of the main causes of injuries. Would you have drones capable of washing PVs on roofs, on rooftops? To my knowledge, not yet. We don't specialize on PVs on rooftops. It's a different market. It's a niche market for NG Green. So not to my knowledge. Yes, there are companies that offer cleaning services using drones. It looks like swimming pool drones. There is an Israeli company that offer that type of service for big surfaces. Perhaps it cannot be used on smaller rooftops, but they use drones and robots. The work can be done at night, which is a great advantage. So there are some companies doing this. I know of a Swiss company and 2 Israeli companies. In France as well, as far as I know, I don't know of any such company here. I represent the company SNC Drones. We are based in the Vaucluse region, and we do clean solar panels. Not only, but we do that. We also clean panels with drones called RS Evolution. Up to 10, 15, or 20 meters high, we can use drones to clean solar panels. We also have a Suru drone that cleans solar panels in a different ways. They are complementary. But yes, you can absolutely clean solar panels using drones. Marianne de Smet, Definder company. I have a question for Taida. In your presentation, you mentioned a load of 3 kilos and a mass above 20 meters. Can you have more than 3 kilos embarked? And what would be the maximum? Thank you. Yes, that's the future for Taida. Everyone wants more weight and mass carried by drones. We seriously envisage, we consider having reaching 150 kilos drones, which could carry 30 kilos. And in 10 years' time, we may have 700 kilos drones, which could carry more. Of course, it depends on the flight technique. We could launch a startup and have a 700-kilo taxi plane, taxi drone, but it is quite risky. Many companies tried and broke their neck after 2 or 3 years. So we do things differently with a solid technical basis. And when we will be stronger, when we will have more resources, we will move along that line. One last question, because we have a schedule to stick to. Please introduce yourself. Hello, Patrice Baum, NG Renewables. I have a question for Taida. You mentioned your drone that can fly against the wind. We know that wind is a great problem for drones. What is your autonomy of your drone? We know that regulation is going to change as of the 1st of January. Drones will have to be classified. Will your drone be in that classification? Regarding flight technique, the surface of our drones allow us to fly in all types of wind. We actually use the wind for the flights. So starting 10 meters per second, we have a significant gain because we have less need for vertical impulse. And after 20 meters, we have a quasi flight and we reduce our consumption by 2/3. This is very different from a multi-rotor because when you have a multi-rotor, the device has to fight against the wind and needs more energy, which is a problem. Regarding the regulation, yes, it's a good point. If we belong to ENAC, it's not a coincidence. We have some offices within ENAC. We work within the union of companies so as to take part to regulation. If we don't have 150 kilo drones, it's no coincidence. We want to be sure of our flight capacity. This is our strategy. We try to properly identify our markets and to have recurrent customers so as to offer drones that are totally adapted to the market's needs. Thank you. Thank you to Arnaud to give us a chance to talk about our drone branch. Thank you very much.